guess it might be. Okay, so hi everyone, I'm Sandra or Patty. The advantage of having two names is that you can choose any of them. So I will talk to you about spectroscopy, spectroscopy technique called transient absorption. Well, I'm a PhD student in Solar Center, and this is one of the equipments that we have in our lab. So a lot of you might be familiar with what it is, the steady state UVB absorption technique. So you basically have a source that will range from like UV to ER wavelengths, and then you will like shine your material with this source. And what you will be measuring is how much of this light is passing through your material, how much is transmitting. And that transmittance is then related with the absorbance by a logarithmic relationship. That is basically a relationship between the intensity of your reference light and the one that is like after passing through your sample. And of course, this follows a Beer-Lambert's law, that is the absorbance relation with what it is the length of the light path, that is maybe your cuvette if you're using like liquids, and your concentration. And this is proportional with what it is a constant, that is the molar absorptivity. So the transient absorption spectroscopy follows the same law, but here what we are actually probing is photoexcited states. So what we're doing is creating them, we're probing them, we're identifying them. And what we are also trying to check is their evolution with time. So how we do this? We have our sample and we will like have two beams. One we will call it a pump and the other one will be a probe. And they will be arriving at different times that we will select. Each of these times will be like a screenshot, let's say. So first we have like our pump that will excite our material, and some of our species will like be excited. Immediately some of them will decay, some of them will decay radiatively, so we will have what is called stimulated emission, which is the basis of the laser. And some of them, while being excited, well, when the probe arrives, will absorb this excitation as well. So we will have what is called a photoinduced absorption. And of course, all of these empty states in our ground level will also give like a bleach in our signal. So we ended up with this spectrum that has all of these three contributions. And we can talk about like this absorption. I mean, it's basically a difference between what it is, the sample with the pump on and the sample with the pump off. And it can be in terms of transmittance or absorbance, or optical density. So here is what I mean when I say these snapshots. So as you see, like for example, when we have like longer delays, then our signal will decrease and eventually will become zero. So we will not have any more photoexcited species. And what we can do then is like having our spectra, then we can select certain areas or certain wavelengths or electron volts, depending on what you like the most, and check what are the dynamics, how they decay with time. Because each of these will maybe correlate with different species in your system. And this is how it looks, the setup. So first we have like oscillator that will generate these pulses, femtosecond pulses, that will arrive first to this amplifier. It's called Legend. It's a regenerative amplifier that will stretch, amplify, recompress the beam. And after that, it will get divided into two. One of them will pass through what it is a optical parametric amplifier, the Topaz, and we will select whatever wavelength we want to use to excite our material. And it will pass through a delay to make this difference in our times. And the other beam that we divide will pass through a sapphire crystal maybe, or another type of crystal that gave us white light. So there are a lot of applications. In general, whatever that is like that light matter related phenomena will take advantage of this. This is how it looks. And the cost varies a lot. So I would just say that it's very expensive. And the resolutions will depend a lot of your excitation time and the probe range. So it's a very, very complex and kind of flexible technique. So it will depend a lot, but roughly maybe more than 900K USD if it's home built. And with that, I want to thank you for your attention.